Welcome to today's webinar, Treating Scale, brought to you by Landscape Management and by our sponsor, Safari Insecticide. I'm Diane Safranek from North Coast Media, publisher of Landscape Management magazine, and I will be your event manager. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. The recording will be available 2 weeks from today on our website, landscapemanagement.net/webinars. A link to the on-demand recording will also be emailed to you when it is available. At this time, I'd like to acquaint you with the ways in which you can participate during today's presentation. Please notice in the lower left-hand corner of your console that there is a Submit button. We encourage you to ask questions throughout the presentation. Just type in the text box at the bottom left, then click Submit to place your question in queue. Questions that were submitted during registration may be covered in this webinar. Some questions may also be answered in an upcoming issue of Landscape Management magazine or in one of our weekly e-newsletters, LM Direct. We strive to answer as many of your questions as possible. Finally, if you experience any technical difficulties during today's event, select Help to submit your issue, and assistant producer Bethany Chambers or I will personally assist you. Now I'd like to turn today's event over to our moderator, Landscape Management Editor-in-Chief, Marisa Palmieri.
Thank you, Diane, and welcome everyone to the second in a series of 3 Build Your Business webinars. Today's topic is treating scale insects, and we have 2 great speakers lined up to cover the technical and business sides of this service. Also, we have to thank our sponsor, Valent Professional Products, and its Safari Insecticide for making today's webinar possible. And we have Todd Mayhew from Valent on the line to say a few words. He's a regional field development manager for Valent. Todd?
Thanks, everyone, for attending today, and thank you to our speakers, Dr. Joe Boggs and Dr. Rex Bastian. Valent USA, Valent Professional Products, and Safari Insecticide are pleased to be able to sponsor this educational seminar, and we look forward to the questions and the information the presenters are giving today. Thank you.
Thanks again for sponsoring, Todd. And up first is our technical speaker, Joe Boggs. He's an assistant professor with the Ohio State University Extension. And just so everyone knows, we'll have time at the end for Q&A, so go ahead and submit your questions, as Diane said, in the question box, and we'll collect them throughout, and then we'll ask them to the speakers at the end. So, Joe, you're up.
Thanks a lot, and I sure welcome this opportunity to talk about a group of insects that are mostly difficult to control simply because of how many different types that we have and sometimes the complexity of their life cycle. So what I'm going to talk about first is some very basic information on scale development. Now, many of you, particularly those with an entomology background, this is all review, but it's just not a bad idea for us all to be on the same page, particularly with what I said a minute ago about scales sometimes having very complicated life cycles. So to get started with this, I just want to very basically talk about how things change with insects. And if you take a look at what you're seeing now, a big cecropia moth developing into a cecropia moth caterpillar developing into the moth itself. And the idea being that I want to put forward is just this idea of metamorphosis. And when we talk about metamorphosis, the first thing that we need to cover is just exactly how is an insect constructed, some very basic morphology. They're wrapped up in an exoskeleton, and it's called a chitinous exoskeleton, which is a lot like a suit of armor. And the point there being is that any time that insect wants to grow, it needs to shed that armor. So that's a very important point in terms of insect development. Just a little side note, that exoskeleton is not made out of the same type of material that our endoskeletons are made out of. That would be bone. This is made out of complex proteinaceous polysaccharides, and that sounds like a pretty complex term, but to just kind of bring it home, when we say proteinaceous, basically we're talking about something like peanuts, and we say polysaccharides, well, basically we're talking about sugar. So in some ways, when you look at an insect, they're wrapped up in a Snickers bar. That's sort of the way to view it. It's one reason why we don't see a lot of insects in the fossil record. But the take-home with this is, as I said, anytime an insect wants to get larger or needs to get larger during development, it has to molt that exoskeleton. So I want to just first cover a type of metamorphosis that we're all most familiar with, complete metamorphosis. And so we'd be talking about something like caterpillars. And, of course, we have quite a few pests that are caterpillars. We're going to look at a non-pest, though, first. Back to the Cecropia moth. And what I have in front of you, of course, is that development that many of us are very aware of. We have the caterpillar. It doesn't look anything like the moth. Eventually, the caterpillar, after molting several times, reaches a stage that we call the pupal stage. In the case of moths, they construct a very nice place to live in, a cocoon in which to pupate, and then what emerges from that, of course, is the adult. So looking on a scale, looking kind of on a graphic scale, all insects start as eggs. Those eggs hatch, and if you're looking at this, you're seeing molt, molt, molt. Now, each time that this caterpillar molts, it passes through something you can see there at the bottom of the graph, first, second, third, and fourth instar larvae. And, of course, as I said, each time that they move from first to second to third, they have to molt. So they're moving from one instar to the next instar to the next. And so this would be something like caterpillars, maggots, if we're talking about flies. If we're talking about scarab beetles, we call those grubs. And eventually the next thing happens, which is very important for complete metamorphosis. We reach the pupal stage. And you can see I have it circled and a line going up to complete. That's why this type of metamorphosis is called complete, because there's a complete change that occurs. And, of course, eventually we reach the adult stage, and this is as large as the insect can get. That Cecropia moth cannot get bigger. It will never molt. That's the end of the development. That's the adult stage, and that's the stage that will reproduce. Now, insects with complete metamorphosis, the rate of development, the speed of development is governed by temperature. That's the primary thing that causes it to go faster or slower. So if we take a look at this graph in front of you, you can see that the warm temperature is going to cause this entire process to go much faster than cooler temperatures. Now, if we take a look at what we're going to be talking about today with scales, scale insects have incomplete metamorphosis. Now, I'm going to use a non-scale insect as an example. And with incomplete metamorphosis, the non-scale insect I'm using is actually a milkweed bug, simply because we can see it very well. And if you notice where I have its development, I have a flashing question mark, because you have the same type of development. Eggs hatch, then they go through molt, 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 first, second, and third. And we call first, second, and third these molting stages instars. But now, instead of larvae or caterpillars, they're called nymphs. And I have the flashing question mark because with incomplete metamorphosis, I'm questioning, well, do you have pupation? And as a matter of fact, you do not have pupation. So with incomplete metamorphosis, what happens is the pupation doesn't occur. That's why we call it incomplete. And so what we see is going from the nymph stage directly to the adult stage. And once again, this is as large as the insect can get. They can't get any larger because there's no molting that occurs afterwards. And, of course, using our milkweed bug as an example, when the nymphs first emerge into the adult stage, you'll get these adults that don't look quite like the adults until they get color, until that exoskeleton hardens up. And so what you're seeing is a newly molted adult, and then to the left, a full-fledged adult. So this is a type of metamorphosis that we see with scale insects. With scale insects, I want to stress something, though. This is why I did all that, is to get to this point where we can talk about a stage that many of you are very familiar with, the crawler stage. Well, the crawler stage for scale insects is actually the first instar nymph. And that's important to remember, because for a number of scale insects, that's the only stage that they can move about. Thus, that's why we call them crawlers. The remaining instar nymphs, second, third, fourth, very often for some types of scales, they settle down. They can't move. So I went through all that just to make sure that everybody clearly understands that with scale insects, you have eggs hatch, then you have these crawlers, first instar nymphs with some species of scale. That's the only stages can move about. And then those crawlers molt into the next stage of nymph that we then call the second instar nymph or third star and fourth. And finally, without pupation, we have the adult stage emerging. And just as with complete metamorphosis, the speed at which this development occurs is very much based on temperature. Warmer temperatures, it occurs much faster than at cooler temperatures. Now, since that first instar or crawler stage is often a targeted stage for control because it's moving about, it can be put in contact with a number of types of insecticides, timing can be critical. It's very important to understand when that first instar stage is going to appear. But since temperature drives this, as I think we're all aware, from year to year, that event can occur at very different times. So calendar dates are not very accurate. As a matter of fact, we used to use them all the time, and many of us are old enough to remember, well, some years, that stage would occur, maybe the first week of May, and next year it's late May. And if the timing's critical, it can be way off, and thus we can have difficulty with control. So this brings up something that you should all be familiar with, and I'm using a website that's based here in Ohio, but there are many websites throughout the United States that links time to temperature when it comes to insect development. And we call this growing degree days. That's the mathematical model that's used to calculate this. And also you can see phenology. Now, phenology is just basically a biological event that's typically associated with some timing. So with the next slide, you can see how this works. In this case, with this particular, before I go to the next slide, I want to point out, with this particular website, you type in the zip code, and of course this works obviously best in Ohio since it's based in Ohio. Just type in the zip code, and then what pops up, in this case Cincinnati, and I just did this, I think, day before yesterday, so we were at 559 degree days, accumulated degree days. If you look right below that, you'll see juniper scale egg hatch is going to happen at 571. As you can tell, then, that's a very good number to know because it tells you need to be out looking when you reach that accumulated growing degree days. Another example would be an insect I'm going to talk about here in a minute called oyster shell scale. You can see there's egg hatch, and that's going to occur for the first generation at 497 degree days. Now, you notice I kind of worked something in there, first generation. Well, oyster shell scale in Ohio officially has one generation. However, you're going to learn in a minute there are actually two different races, and one race has a second generation. We haven't worked out the growing degree days for that. Why am I bringing this to your attention is because this is an ever-developing endeavor. So eventually we'll have that. These numbers are based on the best knowledge available, the best science available today. But if we look at oyster shell scale and you're trying to figure out, well, I don't have access to this website, or this website's not applicable to, South Carolina, or maybe there's not a website there that will do this. If you look below that, Miss Kim Manchurian lilac, boy, that's a very common lilac in landscapes, at least in the Midwest, I'm assuming along the East Coast. And if you see, you'll see that right after oyster shell egg hatch, that's when Miss Kim lilac reaches full bloom. And this succession is going to hold true. As a matter of fact, I should give credit. This was first developed, this website, by Dr. Dan Herms, and he actually did the first work up in Midland, Michigan. And then once he came to Ohio, he's now the chair of the Department of Entomology, but still very, very active in this type of research. Once he came to Ohio, he kept doing this and very quickly learned that the succession remains the same no matter location. So Miss Kim lilac doesn't, for example, bloom before oyster shell scales. It's always after. So that's a pretty good what we call indicator plant. And you say, well, wait a second, Joe. Maybe I want to use something above, like red buckeye. That's not bad. If you look at the top, red buckeye, full bloom at 471, well, that can kind of give you an idea that it's about to happen. I very often like to have something that happens as close right after the event. And the reason being is all oyster shell scale eggs are not going to hatch at the same time. So by having an event that happens a little after as your phenological event indicator plant, it does a little bit better refinement in terms of timing things. So with all that said, let's go now to talking about some specific scale insects. And right off the bat, I'm going to have to distinguish between these two major groups of scales, so-called soft scales versus armored or hard scales. The most notable difference is the scale body. Soft scales, as their name implies, are covered. They're covered in leathery exoskeletons. So you can actually mash them. Whereas armored scales are covered in very hard, waxy shells called pests. The other big difference: soft scales are typically very large, whereas armored scales are very small. Sometimes they're so small that they can be mistaken for resin exudates or something else. Now, the next difference is a little more subtle but can have a huge impact on how fast a population builds. Soft scale females can produce huge numbers of eggs, many more eggs typically than hard scales. Sometimes not many, but as many, for example, as 1,000, whereas hard scales, armored scales, typically per female produces fewer eggs, and some of that's common sense. I mean, a bigger scale has a bigger body and can therefore has more room to produce more eggs. If we look at the nymphs, if we look at that first instar stage, the so-called crawlers, with soft scales, the nymphs and early females remain mobile. As a matter of fact, sometimes with soft scales, we have multiple stages of nymphs that are mobile, whereas with hard scales or armored scales, only the first instar nymphs are mobile. So second instar nymphs all the way to the adult stage are not mobile. That's important to remember because that can help you to target the site where you may be applying your control measure. Finally, with soft scales, they are known to be prolific, many of them prolific honeydew producers. So all this sticky material falls down on the leaves, kind of gives them away, whereas armored scales can remain a little more quiet because they don't produce honeydew. So if we look at this next image, just kind of comparing them, on the left you have a magnolia scale, where on the right you have pine needle scale, and on the left, the lower picture those are actually the crawlers of magnolia scales on the leaves. On the lower right-hand picture, that's euonymus scale, and what you're seeing are both the adult males, the adult females, and I'm sure some of your eyesight's so good you can see the little tiny crawlers. I'm making a joke because those crawlers are in fact very small. So let's talk about a few notable armored scales. And first of all, I want to cover how armored scales feed. Very important. Armored scales, when they arrive, and I need to hang on to it for a second because for some reason I'm not seeing my, okay, so there we go. Armored scales, when they arrive, the very first thing they do is stick their piercing, sucking mouth parts, and it's important to note on this image, into plant cells. So armored scales are feeding on plant cells. They put their stylets into the plant cells, and then the damage done first, the thing that we notice first, is that they cause cells to die. Now, of course, eventually enough cell death can lead to death of plant tissue on a greater scale, even entire areas killed. And so if we take a look at some of the damage caused by armored scales, if you look at this euonymus scale picture, you see those little areas of chlorosis on the leaves. That's produced by this feeding behavior on the individual leaves. So let's dig a little deeper with euonymus scale. And so there we have the underside of a euonymus leaf, and mostly what you're seeing there are actually the male scales. And so to kind of zoom in a little bit more, afterwards, here I have an image showing when you have that high a population, how it can cause plants to die back, cause them to thin out. Now, it's hard to kind of imagine with euonymus, with winter creeper, for example. I mean, that grows all the time, seems to be a pretty hardy plant. imagine the population density required to cause this type of a dieback. Now, one thing that I want to skip ahead just very, very quickly, and while you're looking at this slide, one way to manage scale insects is to be mindful of managing plant health. You got to be very careful with that, though. What we want to make sure is that the plants are not stressed by such things as drought. We hope that they're in a good location, good soil, that sort of thing. We hope that proper fertilization is done, but I want to stress something. Be very careful not to over-fertilize with nitrogen, because these scale insects, both the hard scales and the soft scales, they do very well with the increased amount of amino acid that's produced when you have high nitrogen. I don't want to go too far with that because I'm painting with too broad a brush, only to say that it's good to focus on plant health, but if a little bit is good, a lot's not better. And so be very mindful that over-fertilization can actually lead to increased scale populations with some species of scale. Now I have a zoom in showing exactly what you need to see, and unfortunately, maybe those crawlers are even so small my slide doesn't show it as well, but you can see the white material, those are the male scales. The kind of oyster-like, I don't want to get too carried away here because we're going to talk about oyster shell scale, but the oyster-like structures are the females. Now, the females are settled. They're stuck to the leaf. But what can move about are the little tiny dots on here called crawlers. Those are the first instar nymphs. So just use your imagination. If you have that female stuck fast and really adhered to that plant epidermis, well, you're not likely to contact it. That hard test or that hard shell is going to protect that scale from contact insecticides. The crawler, on the other hand, can be killed by contact insecticides. Of course, remember that female is going to be feeding, and that does lead to the possibility of using systemic insecticides. We'll talk about that in just a minute, but there are 3 challenges with this scale. First, there are 2 generations with extended egg hatch, and these generations often overlap. I have to be honest, here in Ohio, it's been very hard for me to see the change between first generation to second generation. That egg hatch for the first generation goes on for so long, it's almost like it's continuous, which really does make it a challenge in using contact-timed insecticides. Also, this scale can remain hidden on stems, making it hard to detect, particularly if it's on a plant, where a lot of pruning is occurring and those leaves are being cut off. The final point with the first 2 points combined is that populations can build very rapidly, can seem to come out of nowhere. Now, in terms of management, this is going to be something that we're going to have to kind of address along the way, because in this case, dormant oils provide almost no control. You got to read the rest of that sentence. That's because this scale winters in the egg stage. Now, we had a question that came up before we started about gloomy scale, and gloomy scale actually overwinters as females, does not overwinter as eggs. So with gloomy scale, for example, dormant oils can have a good effect as long as there are not so many scale bodies that you can't get to the females. Scale bodies mean being piled on top of each other. But dormant oils have almost no effect on eggs for a simple reason. Oils and soaps have to penetrate the insect. In the case of eggs, there's usually only one hole. It's the hole that was originally used for the egg to be fertilized. And frankly, you're relying on the oil being able to penetrate that one very, very teeny tiny hole, and it just doesn't happen that often. You can also go after euonymus scale with targeting the crawler stage. That's where oils, horticultural oils, can come into play, although I say highly limited. The reason being is because if you have an extended period of first instar crawlers, first instar nymphs, then it means that with soaps and oils, as I said a while ago, they're contact insecticides. They don't remain active for something to crawl through. You actually have to coat the insect, and of course that means multiple applications. Pyrethroids can work a bit better, but once again, you need to, they only last a certain period of time. Also, contact, so that means multiple applications. Also with contact insecticides, remember that you can also contact the biological control agents. And Rex is going to talk more about that later, but biological controls can play a major role in reducing scale populations. And this does bring up then, okay, how might we use something that doesn't affect the biologicals quite as much, that can have a little bit longer activity? Timing is still important, but maybe a little less important, and that would be the systemic insecticides. Such things as dinotefuran or safari or transect, acetamiprid, or I have flunicamide, the Araya, that is used primarily in greenhouses and nurseries only. But back up, I want you to notice that when I talked about dinotefuran and acetamiprid, I have both soft and armored scales listed. That's very, very important. As a matter of fact, you'll notice on this particular slide, I don't have another very common systemic insecticide that you're all familiar with, imidacloprid or merit. That's because imidacloprid is not effective against hard scales. It is effective against soft scales. And I have this particular image in here because I just want to emphasize, here's a little tiny, it's kind of hard to even imagine the size of this tiny Stethurus lady beetle. There are several species. But these biologicals, beneficial insects, can have a significant impact, and so I just want to make you aware of that. I talked about euonymus scale because it's so common. However, the one that actually causes, in my opinion, a greater amount of harm and potentially greater destruction is oyster shell scale. Boy, this scale seems to be coming out of nowhere in recent years to become very common in landscapes. One reason is its very wide host range. You can see I have three pictures, a tree, a shrub, and a ground cover, ash, knockout rose, and pachysandra, same insect. So with oyster shell scale, you have a tremendous host range. Can build up on one, move to the other, and so therefore populations can build rapidly. With this scale, in particular, you can have such a high density of scale bodies that those bodies of dead females, for example, can protect the crawlers from contact insecticides. So that's another problem. And then I referred to this earlier. This scale actually has been found to have two races. Now, this information is best identified or has been better worked out in Indiana, where we see a gray race with one generation and a brown race with 2 generations per year. So just the idea of the life cycle being a bit complex based on these two different types also presents a challenge. In terms of management, contact insecticides, I almost put this in caps, a real challenge. Obviously, timing it to target the crawlers is critical. But remember that those dead bodies of the females can seriously reduce contact to the insecticides, meaning oils really don't work well. Soaps are highly limited as well. Some of the so-called boar sprays, special formulations of pyrethroids that tend to stick and last longer, such as onyx, can provide some control. Once again, though, we're going to focus back on, and you'll notice that this is exactly the same list I used with the euonymus scale, the systemic insecticides being effective for exactly the same reason as I mentioned with euonymus scale. So some notorious other notable hard scales. Pine needle scale can be a real challenge, particularly in production. And I'm showing you one that is a bit sneaky. Black pine leaf scale, and as you can see, it's very different than the white pine needle scale test. Black pine leaf scale tends to show up on the hard pines. Geographically, it's very localized, but it's one that can appear and cause considerable harm very quickly. Elongated hemlock scale. Many of you are dealing with hemlock woolly adelgid. Well, here's another insect on the hemlocks that can, in fact, stress the trees. If you look and make them more susceptible to depredations of hemlock woolly adelgid, if you look to the right, you'll see this stippling, which could also be mistaken for one of the mites, could be mistaken for, let's say, spruce spotted spider mite that's very common on the hemlock. And so sometimes I've seen the elongate hemlock scale be misidentified because of that stippling as being a mite problem. So be aware of that. The final point with elongate hemlock scale, this is a Cilician fir, and so elongate hemlock scale has a wider host range than its common name may imply. It can appear on quite a wide range of conifers. Now, with the remaining little bit of time I have, because I want to try to keep this about 30 minutes, let's talk about the soft scales. And just as with the hard scale, I want to start by talking about how soft scales feed and how it differs from hard scales. And if you notice from the same graphic, I have the little scale with its piercing, sucking mouth parts inserted in the plant. But notice what it's inserting into. It's inserting into the phloem vessels. So this insect feeds very differently than the hard scale. They tap into those phloem vessels. Now, a little cell damage is done where their piercing, sucking mouth parts pierce through the cells, but it's really inconsequential. You almost, in fact, don't hardly notice it. The real damage occurs because these insects remove large quantities of liquid. Now, what they're doing when they tap into the phloem vessels is they're removing a lot of sugar water. They will feed on a little bit of that carbohydrate, but what they're mainly after, in all that big flow, that garden hose or fire hose of water coming out of that phloem vessel, they're trying to extract amino acids. So they have to remove a large amount of liquid to get to that little tiny amount of amino acid, and that presents a challenge, a waste disposal problem. They have to avoid that somehow, and the way they do it is to avoid it out the back end in the form of this sticky, sugary substance that we call honeydew. It's a little bit like scale diarrhea. I hate to say it that way, but that's exactly what it's like, and so that is exuded out. We can see this dripping on plants like this witch hazel leaf. By the way, the dripping was coming from Calico scale. We're going to talk about in a second. And, of course, whenever you have honeydew, that sugary material can be a food source for black sooty molds. So here we have a magnolia leaf covered by black sooty mold. Doesn't directly harm the plant. Of course, if you get a heavy enough buildup, you can have a reduction in photosynthesis, but it certainly makes the plant look bad. And if you look to the right, that's actually Calico scale on a honey locust, and look at the blackening on that stem. Now, that was actually caused mostly by the crawlers. We'll get to that in a second, because the first soft scale we're going to talk about is Calico scale. Once again, very wide host range. If you notice at the bottom, I have a list of trees and shrubs, and the fact of the matter is I have et cetera, because it's a very wide host range. And an example I have in front of you is witch hazel. It's a non-native insect, but it's been with us for quite some time. And as I mentioned earlier, it's very important to understand, regardless of the scale, it's important to understand the life cycle so that you can better target your management efforts. In the case of Calico scale, if you went out in the winter, you'll find all these dead, dehydrated brown females stuck on the bark. But you'll also, if you could look very, very closely, you'll find live late instar crawlers on the bark. Now, I've kind of mixed some words up here, because you're thinking, wait a second, I said, that the crawlers are the first instar. Well, soft scales, in this case, because all instar nymphs can crawl, they're all called crawlers. I'm bringing that to your attention because we have some rules with names that get broken sometimes when you're reading about this in the literature. Sometimes you'll see, all right, the second instar crawlers, third instar. That's telling you that all the nymphs are active and mobile. In late spring to early summer, and of course this should be happening very shortly, the females mature and they start producing copious quantities of dripping honeydew. This can really give the scale away, dripping down onto patio furniture, onto cars, on the sidewalks. Can create quite a mess. Now, in the summer, sometime during the summer, and of course, if you really want the timing of this, growing degree days can help, but in the summer, the females become fully mature, and you can see that this characteristic covering makes them kind of pretty if you're an entomologist. It's black and white checkering. If we look closely, actually I missed a slide here, but from those females, then they will produce eggs, and from those eggs, we get the first instar crawler stage. And back when we were trying to just time the crawlers, just make our applications and time the crawlers, two-sided sticky tape was very, very helpful. That's what this picture shows. And you can see from the size of the penny, these are very, very tiny insects. But with such numerous quantities of the crawlers, they're pretty easy to see on the two-sided sticky tape. Now, this scale does something very different than you'll see with even a number of other soft scales. In midsummer, those crawlers move to the leaf veins. Now, I want to be very, very deliberate here. This is also the same type of life cycle as some of the other soft scales, such as cottony maple leaf scale, but this is not the way that other soft scales work. So once again, I keep stressing this idea that one size does not fit all when it comes to development of scales. You need to find out exactly where they are in their different stages of development. In this case, the crawlers move to those leaf veins, and while they're there, and I have a close-up shot, you can really see them gathered around that mid-vein. They're feeding just like I showed soft scales feeding, and they are exuding honeydew. As a matter of fact, I've actually seen more honeydew production from these crawlers of calico scale than from the females. And also, I've seen more damage caused by these crawlers because you have a tremendous amount of moisture, of liquid being removed from the plant. I've seen more damage than caused by the females. So if we look at control, targeting the overwintering crawlers, there's been some research showing that pyrethroids such as tall star can be effective, but I have to tell you, results by arborists and landscapers have been inconsistent. So that's something just to bear in mind. If you do target crawlers with the active crawlers on the leaves in the summer with pyrethroids, once again, timing is very critical. But as with the hard scales, the systemic insecticides can be your friend. In this case, imidacloprid, the Merit or Marathon or Zytec can be effective, as well as the dinotefuran that I mentioned earlier. In this case, I have examples, Safari, but also Transect. I should have had that in there. And, of course, this can be very effective in prevention of egg hatch, or actually egg production. Imidacloprid, clothianidin, and dinotefuran can also be applied in late season to help to minimize the impact of this scale. But once again, I want to stress that as with all scale insects, beneficial insects can play a tremendously helpful role. In this case, twice-stabbed lady beetle actually moving underneath. As I watched this lady beetle, she was crawling underneath these females and kind of feeding on the soft underside of the females from the inside out. In recent years, we started developing a real challenge with tulip tree scale. With tulip poppers becoming more and more frequently used in landscape, this is something to be aware of. And with tulip tree scale, you have a little different life cycle, but you have that same soft scale look to the scale insect. And I don't know if you can see it, though, very well, but what I'm pointing out is that the crawlers, the dead crawler bodies, are telling us that they were parasitized because there are holes in the crawlers. I should have pointed that out all the way back with the black pine leaf scale. When you see holes in the scale's body, that means parasitism has occurred. And quite honestly, if you look at the number of crawlers that were killed, I would say over 50%, maybe even greater, of the crawlers are actually parasitized and died, as compared to the females that you see on there. So they can have beneficials can have a pretty tremendous impact. The next image shows something, though, that I want to stress with this particular scale. On the left, you'll see a leaf that does have black sooty mold. This is a prolific producer of black sooty mold. On the right, you'll see tulip trees that are showing brown and yellow leaves. Now, the symptoms to the right are not from the scale. This was taken late last summer in southern Ohio, and we were suffering, as you can see from the turf grass, we were suffering through a pretty substantial drought. And, of course, tulip trees are one of the first trees to show, drought damage by their leaves turning yellow and then eventually brown and start shedding leaves. So those trees were not infested with scale. And I want to point that out. I had another image of a tree to the left that had scale, looked the same, but the scales were not causing the discoloration. Now, in terms of tulip tree scale, I'll go through this kind of fast. I want you to kind of compare and contrast what I talked about with Calico. We're seeing pretty heavy infestations in Ohio forest and landscape, particularly southern Ohio. But this scale always remains on the bark throughout its life cycle. You do not have those crawlers going to the leaves. So winter is spent in second instar nymphs on the bark. Mid to late summer, the males and females mature, mate, and the females suck juices and develop. But again, it's on the bark. Early fall, females give birth. And this is kind of interesting because the eggs are inside the females and they hatch out. So it's like they're giving birth, although they did produce eggs, to as many as 3,000 first instar nymphs. So now you can see why this type of scale can develop so quickly. Of course, those nymphs settle in the bark and begin feeding, and that's when we start seeing a lot of trouble. Magnolia scale, you probably thought I would have started with magnolia scale because it is almost like the poster child for soft scales. It is one of our biggest soft scales that we have in the U.S., very easy to see. Magnolias are very popular. The reason I started with Calico, though, is because Calico scale has such a huge host range. Magnolia scale, as its name implies, is relegated to magnolias. Now, keep in mind that tulip tree is a type of magnolia. Occasionally, you will see magnolia scale on tulip tree. It's very rare. And occasionally, you'll see tulip tree scale on magnolias because, again, they're both magnolias. With magnolia scale, very large. That's a poster child because we can pull them off. You can see from this image, I mean, look at the size of the scale on a dime. And what you're seeing on the lower right-hand side flipped over are, in fact, the eggs that are beneath that female magnolia scale. A few other notable soft scales with the rise of American elms, the selections of American elms that are resistant to Dutch elm disease. European elm scale is a bit on the rise. Remember that those elms are resistant against the fungus that causes Dutch elm disease, not resistant against scale insects. Just to kind of wrap up with my parade of scales, if you will, striped pine tortoise scale, just to point out that we do have a range of soft scales that can occur on conifers. This is one that could present a serious problem if left unattended, if not diagnosed and not handled. So I'm going to turn the program, and I'm sorry, Rex, I went a little bit longer than I promised, but I'm going to turn the program over to my colleague, Rex Bastian, and so he can finish with some further information on managing scale insects.
Thanks, Joe. Welcome, everyone. It's a fine afternoon, and we're going to wrap up our presentation with a little bit more about some of the options you may be thinking of as far as managing these scales out there in the landscape. What are some of the challenges that you're going to have to run into and the things that you're going to have to consider? First of all, I didn't actually put it on here, but I should have. Before we're starting to think about managing any type of scale, we have to make sure that we are complying with our state laws and regulations. Those things vary between states. Some states are much more strict in who can actually manage the scales or even make recommendations about managing them. And those are going to vary from state to state. Some states you have to have a license in order to make diagnostic recommendations. Other states you can make applications. You have to be working under the supervision of a licensed pesticide applicator. So that's going to vary from state to state. So once we're out there in the field, we need to be aware of what species and hosts are those targets for those scales that are prominent in our area. Some areas of the country, especially down south and the southwest, can have a lot more scale insects than in the Midwest and upper Midwest. So we need to be available with what's going to be our main set of possibilities. And we're going to do that via education. We're going to learn about the different scale insects And so we're going to do that through in-house education. If your company will be teaching you on things inside your own company, you're going to be relying on our great extension people like Joe and attending seminars and using the internet and your extension resources in order to help you identify the insects that you're going to have to work with. Certain organizations will put out timely newsletters about what is happening. They're seeing crawlers of this particular scale insect now coming into the clinics within your state. So you're going to be using all those different things in order to help you identify these insects. And we really need to be paying attention to those such as euonymus scale and magnolia scale as a couple examples, because these are killers. Some scales can be present, but the plants can actually tolerate fairly heavy numbers of them. But certain scales, such as we saw Joe's presentation with euonymus scale, this is showing magnolia scale. These scales can be killers, and if they build up to a certain number, they can actually kill that plant. And so we're going to be paying more attention. That's our key plant, key pest concept, and we need to know what those plants are in our given area. That's going to vary from location to location. So then we're going to, if we've identified our scale, and we can also use extension resources to help you identify, you may be able to send in a sample to the clinic. Once again, some of these things are very, very difficult to identify. There can be different types of scales that look similar, and so having a little extra help from your state extension specialists can be invaluable. So we want to identify that level of an infestation. Are we dealing with a light infestation, a heavy infestation? We're going to be looking at observable effects on growth. Are we seeing any dieback? Obviously, we're looking here at magnolia again, that upper photo, and we're starting to see the decline in the canopy. That's telling us that, hey, we might have to attack this much more aggressively than, say, I walk around a landscape and I notice my magnolia, and then I'm seeing some honeydew beneath the plant that indicates the presence of magnolia scale, and then I'm looking up, but I don't really see a lot. That means I may not have to attack it quite as aggressively based on what I know about that particular case. A lot of times we don't mess around a lot with magnolia scale because we know how damaging it can be. So we're going to be always evaluating this in terms of assessing how much scale we have and what type of threat can it pose. We're also going to look at the scale population and say, hey, is it viable? Is it actually alive? In a lot of cases, dead scales can look the same as live scale. This can be especially true with the armored scale infestations. You'll have a crust of those waxy pests building up on the plant, and even if they're non-functional, you can still see them. They may be on the plant for many years. So oftentimes with, as an example, what I'm showing here in this upper slide with euonymus scale, I've grabbed that twig and I've twisted it, and I'm getting all the juicy parts of that scale population on my fingers. And euonymus scale eggs and adults underneath there are kind of a yellow color, and I'll get that yellow color transferred onto my fingers. If I could rub that stem and it's all dry and I'm not getting that yellow mess onto my fingers, then that could mean that I've got an old scale infestation, but it isn't actually functional at this point. We can use a knife blade, we can use anything that we can scrape, we can hold a dark piece of paper or a light colored piece of paper underneath my scrapings, and then with a small hand lens I might be able to look and see, can I actually see any eggs, depending on the time of year where I'm at. That lower slide is actually showing the eggs that are present underneath the shell of a lecanium scale and I've knocked that scale cover off, and you can see all those eggs that have dropped off. You remember that Joe said soft scales can produce multiple hundreds of scale eggs for each female. And so that's what I've actually seen there. I'm popping off that scale cover, and all those dust-like eggs are dropping off, and I can observe that with a little bit of investigation. I'm going to assess that population in terms of the presence of natural enemies. And the upper photo there is showing an oyster shell scale infestation that has built up over many years into this whole. You're looking at scale insects there, not actually the bark of the host plant. They are so thick, but you can't really see it there, but under a large view, as I'm looking over those scale insects, I don't see very many holes. There's very, very few holes in the shells or the tests of those scale insects like I'm seeing in the lower slide. And there's maybe 1, 2, 3, 4, 5 or so scale covers, and I can see that there are holes in 3 or 4 of them. So in that particular case, those holes cut in the shell or the test of that scale insect were made by parasitic wasps that have emerged and are doing a pretty job of controlling the population. So it's monitoring the scale and looking for, do I see a lot of these holes? If I'm seeing a lot of these holes, I'm scraping and rubbing, I'm not finding a lot of eggs, perhaps my population isn't to the point where I need to actually do anything about it. Okay, let's see if this is a little better. I see I'm getting some feedback questions here, so we'll try this a little bit different. Once we've assessed our population, we're going to be thinking about management options. We're going to formulate management options that we can use to tackle the situation that we're dealing with. So in this case, we're looking at cottony maple scale on a silver maple, and that upper photo is kind of an overview shot. And if you look underneath on the driveway, you'll see this stain, and that's honeydew that has been dropped off of that scale population. And then the second shot, I walked underneath the tree and looked up, and all that white that we're seeing underneath those twigs up above are egg sacs that have been produced by the cottony maple scale females. Now that's very noticeable. Your clients may be able to notice that, but the issue is because those are egg sacs and inside of all that white cottony material are the eggs, that even though it's very obvious, your ability to manage this population at this particular time is very limited because of the fact that those eggs are protected inside of that cottony mass. There's no feeding really going on at this point. So if we would go in and say, treat this tree by trying to spray it with an oil or an insecticide, we're essentially not going to have a whole lot of luck because the insect is actually in an invulnerable stage at this point. So just because you can see the insect at this time doesn't mean that this is the appropriate time to treat. Well, how are we going to sort all those things out? And that's where we need to have that knowledge about our host insect complex. What type of tree size are we dealing about? Is spraying even possible on a large tree? It might not be. How much symptom expression? Are we dealing with an intense scale infestation or a light scale infestation? Are we dealing with an armored versus a soft scale? Are we dealing with a serious versus non-serious species? Do we have multiple generations involved? What's the current time of year in relation to the pest life cycle? As we just said, at this particular time this photo was taken, we had options kind of before this during the early dormant season where we could have used a dormant oil. We have options a few weeks later when those crawler those eggs are going to hatch and the crawlers are going to move out to the leaves where they can become susceptible to some of our systemic treatments, but at that particular point, they're not susceptible. Where are we at in time of year for our treatments to work? In other words, we have several systemic materials that are available to us, such as imidacloprid and dinotefuran, but they move up the tree at different speeds. So there's a lot of things to consider as we consider what particular option we're going to take. Management options: can we apply foliar sprays? Maybe. We don't have to do that as often today because we have other materials available that we didn't have available to us 20 and 25 years ago. Foliar sprays can be very difficult when we're dealing with larger trees. They may not be as problematic if we're dealing with shrubs or scale insects on smaller plant materials. We have soil applications available to us. We have some materials like dinotefuran or safari and some of the other materials that are labeled for lower trunk applications, that the material can be applied to the lower trunk, it can be absorbed into the tree and moved up into the tree. We have systemic versus contact insecticides. We have biorational materials, soaps and oils, growth regulators. We're finding growth regulators such as distance is very effective on a spray application for armored scales such as euonymus scale. We've been very pleased with some of our results along those lines. We need to consider the residual effect of the material. Some materials will last longer in the tree, even multiple years in some cases. If the material is systemic, what about how quickly does it move up into the tree? Imidacloprid moves fairly slow up into the tree. Dinotefuran moves quicker. So depending on where I'm at in the insect's life cycle can make a difference into what material may be most appropriate to get the coverage up into the insect where I need it, because we need to have an intersection of the insect life cycle, the chemical, and having those two meet, and how we time that out can be extremely important in whether our treatment is going to be successful or not. We need to consider side effects. Off-site movement. Do we have the potential for water coming in and flooding an area, heavy rainfalls that are in the forecast? All these different things play into what particular technique or combination of techniques I might want to use. Some systemic chemicals can trigger mite outbreaks, and if we manage one pest, we might end up with other problems. Trying to manage elongate hemlock scale on hemlocks using imidacloprid too often can trigger a problem with spruce spider mite on those conifers. And we don't want to supplant one problem for another. So in some cases we have to be very judicious in how we use these materials, as well as on non-target effects. Can we get drift? Could we get an effect of a material moving away from my plant onto some other plant that I don't want to affect? I need to be cognizant of the chemical cost. You can figure out what your material costs are per inch of caliper or for foot of shrub height, and then we can use that. And that can be kind of sneaky. Some materials can be applied both as a foliar treatment and as a soil applied treatment, and they can be quite inexpensive to use as a foliar spray, but they can start adding up fairly quickly if you are using them as a soil treatment. So once again, a lot of things that come into this particular consideration. As I look at some of the industry trends that I have seen in the 25 years that I've been looking at scales, I've seen an increased use of biorational materials for foliar applications. So more in soaps and oils, both as a dormant application as well as a at a lighter concentration in the summer. And probably one of the biggest things is the rise in insect growth regulators such as distance that we found to be very good for managing some of those tough armored scale insects. We've also seen an increased use of soil and bark applied systemics, especially for soft scales on large trees. In the old days, we kind of had to wait, either do a dormant application in the early spring or wait for those eggs to hatch from those females, and then the crawlers moving out to the foliage, and then we would use targeted summer treatments to apply to the foliage in order to try to get those crawlers as they were feeding. Well, because those soft-scale crawlers are really tapped into the parts of the plant that move those systemic materials most efficiently, we don't have to do that anymore. We can use that soil-applied material, and that material goes right up there, and it's really targeted into those little crawlers as they're feeding. So, and in a lot of cases, those applications have replaced many of those early spring dormant oil applications simply because we don't have to spray these large trees anymore, and that's very beneficial to us. So that's kind of wrapped up some of the things that we've got that I have, and I think we can turn it back over for Q&A.
Great. Thank you, Rex, and thank you to Joe, too. You guys both did a great job. That was a ton of great information. We have some questions that are rolling in and also some that people supplied before when they were registering. So here's one for you, Rex. I know you already touched on insect growth regulators a little bit, but this question specifically is about what's your thought on using an IGR tank mixed with a pesticide like Safari or as a standalone? Do you have any thoughts on that?
I'm not, necessarily a big one for, tank mixing things. Sometimes a little bit of oil mixed in with something can kind of help, but we haven't actually tank mixed. We've actually used that insect growth regulator by itself. Now, you do have to watch the label in that some of your growth regulators are restricted to limited number of applications per year, and that's to help reduce the chance of our target pest developing resistance. So oftentimes, and that can run into, for example, on euonymus scale where you've got 2 generations, you may use the IGR for the first generation and then maybe a different product for the second generation. I like to keep things separately. Sometimes you can look at cost. There can be some cost versions, and sometimes I look at it's just a little bit more things that can go wrong when I start mixing materials together. So I would always try to use something by itself first, unless I have good recommendations from an extension service that those things through trials have worked very well.
Okay, great. Another sort of application question. I guess this would be for you again, Rex. What PSI and spray angle tip would you recommend for using a power washer for physical removal of hard scale on privet or euonymus?
Well, you want to make sure that you would use something where you're not stripping through that, stripping through and removing the bark. We've actually, going back to blowing that off, it's going to be that, if you use a pressure washer and just water to try and blow it off, if you're blowing the bark off, you've obviously gone too high. So it's going to be a, kind of adjust as you go. Didn't mention it here, but for things like prunicola scale or white peach scale, on certain plants we even use brushes to brush off those scale incrustations. But just to have a figure in my head, I'd work at it and try to use the lowest pressure that I could get the scale off but not damage the bark at the time.
Yeah, I want to weigh in. We've actually tried a bit of that. I realize the intent here in terms of trying to avoid, perhaps using an insecticide to do some physical removal. But the experience I've had with doing this for a hard scale, and I'm not sure which one exactly that when you say hard scale and privet or euonymus, is that to detach those scales, particularly the females adhered, I have to be honest. When we've done it, we've never done it without causing significant harm to the plants. But something, Rex, you touched on this, and something that can be very helpful. Now, for example, the picture of the oyster shell scale on knockout rose was my own knockout roses, and I handled the infestation by pruning. It just turned out it was on a few canes. They really built up. So monitoring and pruning, it's a physical removal, and if the plant allows it, might be a little bit less damaging than trying to use a pressure washer. Again, very difficult to have that pressure right. They're not typically designed to do this type of work. They're designed to strip things, and so it'd be awfully tricky. And then plus, you're going after a circular target, and as I think our physics would tell us, you're going to have the greatest amount of impact on a very small area of that circle. And so if you're trying to go all the way around the stem, again, our experience was we either damaged it or didn't do the job.
Yeah, the other thing too there is that your care of your shrub, putting your shrub on a rotational pruning program where you're taking out those oldest stems and letting new stems build up. And sometimes you see those big scale incrustations on those real large stems, and they aren't the ones that are necessarily doing the best for you. On privet, those large stems are going to have ash borer in them, and so just getting them out of there by mechanical removal and letting the shrub replenish itself with new sprouts coming up from below can help with several pest problems, as well as improve the actual health of your plant.
I see a question. I'm jumping ahead just very fast because I see the next question, and I apologize if I didn't make this plain. I think it's when I was starting to realize the time was running short for me. The question being, is oyster shell scale a hard or soft scale? It is a hard or armored scale. It's not a soft scale.
Okay, great. Thank you for seeing that one. Joe, do you have any input on scale on young red and sugar maples?
Well, and that's and Scott, I see you've asked that question, and I saw that actually before we started. It comes back to those hosts could have multiple types of scale, and so I'm not dodging the question, but here's how I would handle the question, and if that arrived as an email, I'd say, well, could you get me some images? Could you send me some pictures, and even verbal descriptions for scales. Rex, I know you've had the same experience. We've all had the same experience. A verbal description, I can't describe some of these scales very accurately without sounding like some of the others. So one thing we didn't touch on in terms of diagnostics, identification aids, when you're working with anyone, be it extension or other resources, I tell you, a picture's worth 1,000 words. So doing a nice job of images, and I'm not getting a soapbox, but unfortunately, with many cell phones, the camera built in, the lens size is so small it doesn't do well with macro photography close-up. So spend a little time, and maybe something that you want to invest in with your company so that, or your company may want to invest in, to have some photographic equipment, at least one decent camera, so that when you ask for an identification, which will then set the stage for all your management down the road, you're going to get an accurate identification. And Rex, I know that you kind of touched on it. We did touch on it, and that is that scale management can become very costly. Your costs can really skyrocket, particularly if it's a misidentification. So if you look at the cost of decent cameras and the cost of making an error, I think it comes on down on the side of having a decent camera.
Yeah, a lot of times even with the cell phone cameras, if you clip off if you can clip off a piece of the plant and then put it on a surface to take your photo, because that will help the camera focus on a single plane, and that'll help quite a bit. When you try to shoot a twig with a cell phone camera, the camera is looking at the ground behind it, not what you really want it to photograph. And I know there's another question here, best way to control gloomy scale on maples and willow oaks. I tend to think of gloomy scale more as a maple problem. On willow oaks, and that might be one there. Are we looking at obscure scale on the willow oaks versus gloomy scale? You usually think of obscure scale on oaks and gloomy scale on maple, so you might be dealing with two different scale insects there. No, they're similar in their life cycle and things. So the management approach would probably be similar, where you could look at a dormant application, depending on the size of the tree that you're working with, a dormant application or the use of those growth regulators or summer oil applications to try to get the crawlers. But armored scale crawlers don't fight fair. Sometimes they don't sometimes come out in the open like we oftentimes get with our soft scale crawlers, and it just makes them much more difficult to manage. Soft scale are much easier to manage once you've got a proper identification.
Well, and I tell you, Rex, we could have done an entire presentation on just the armored or hard scales. I agree with you entirely that when just on the surface, and even I have to tell you, even just walking up and in the field with the amount of time you and I've spent, sometimes separating some of these armored scales is a bit difficult without doing a little digging and finding out what life stage is there. Because some of those, I kind of mentioned that one with the euonymus scale, and I said they look like little oyster shells, and I realized, I was going to be talking about oyster shell scale in a minute. They actually both look like oyster shells. So some of our common names for the armored scale even can throw us off a bit. So I agree. Jonathan, you may want to take a look more closely. I was wondering about that as well, Rex, as to whether those are the same scales.
Yeah, and also too, it might take a couple years to clean up a bad scale infestation. Some plants give you that time frame, other ones may not, depending on when you catch it.
Well, I hate to cut you guys off because you're heading down such a great path. I think you could both probably talk about this all day. And people have stayed on the line, and so clearly our audience is very interested. But we've gone over 70 minutes now, so we're going to wrap up. And I just really want to thank you, Joe and Rex, both for your great presentations, and thanks to all of the attendees. We really appreciate your support. Thanks one more time to our sponsor, Valent and Safari Insecticide, for making today's webinar possible.
Well, likewise, Rex, I really do appreciate team teaching with you. This has been a lot of fun, and look forward to working with you in the future on other things. And I likewise want to thank our sponsors, and in particular Landscape Management and all the folks that hung on through my extended stay, which I didn't mean to take that long. So thanks, everyone.
Me too. Thanks, everybody. Certainly appreciate the time to work with everyone.
Okay, great. Diane?
Thank you so much for attending. I really appreciate your attendance. Thank you.